Okay, so this video is a continuation from the previous video where we talked about things that are inscribed. And so now we're going to go into more specifically talking about quadrilaterals that are inscribed inside of a circle. So this is my beginning slide in the PowerPoint. Here's a couple of examples of quadrilaterals inscribed in a circle. Okay, so there's a special term for quadrilaterals that are inscribed in a circle, and they're called cyclic quadrilaterals. So that's going to be the first thing that we put up at the top here. Okay. So a quadrilateral inscribed, let's put a little box here, in a circle is called a cyclic quadrilateral. Okay. Cyclic, kind of like cycle, which is referring to things that are circular, like, the water cycle or, a bicycle, that kind of idea. All right, let's do two examples of what cyclic quadrilaterals look like. So let's see, put a center here, make it about this big. Okay. Put another circle over here, about that big. Okay. All right, so I'm going to put 4 points on this circle. Okay. Okay, so that's what one of the cyclic quadrilaterals, that's one thing that it could look like. I'm gonna attempt to do kind of a rectangular shape in here. Let's see if I can pull this off. Okay. All right. A little bit. But yeah, you get the idea. So basically, any quadrilateral that's inscribed in a circle is called a cyclic quadrilateral. Now, just like inscribed angles have special properties, cyclic quadrilaterals also have special properties. So there is a corollary, and it says that in a cyclic quadrilateral, the opposite angles are supplementary, meaning that they add to 180. So what this is saying is that if we were to add angle A and angle C, those would be equal to 180. Also, angle B plus angle D is equal to 180. Okay, so we'll write that down. So, next section we have a corollary. In a cyclic quadrilateral, opposite angles are supplementary. Which, remember, means that they sum to 180. So let's put a picture in here of a cyclic quadrilateral. I'll make this one mildly bigger. Not the same size as the other ones, but whatever. Okay. Okay. Connecting those points. Okay, so this is A, B, C, and D. So, again, what this means, okay, is that angle A plus angle C would be equal to 180. Okay, so this angle here, okay, plus this angle here, these are supplementary. Okay. Also, angle B plus angle D would be equal to 180. Opposite means across from. So in a cyclic quadrilateral, in this picture, A and C are across from each other, and then B and D are across from each other. So those are the opposite angles that are supplementary. Okay, so for this next part, what we're going to do is we're actually going to look at the proof for why this is true, why this corollary is true. I'm not going to put the proof on the same page. In fact, if you want to draw a line here, okay, we're going to use this bottom half of the page for an example, which we'll get to in a minute. Okay. But on page 5, okay, this is where I suggested that if you wanted to copy the examples from the other video, you could have put them up here somewhere. I'm going to put the proof on here too. You don't have to copy down this proof by any means, okay? If you want, you can just watch along or you can skip ahead. I personally think that seeing the proof sometimes helps you to understand the theorem or corollary a little bit better, because it helps you to understand why it's true as opposed to just memorizing a fact. But you don't have to write this down. Of course, this is optional. All right, and really all of this is optional. So, okay, let me take a look here. All right, so our goal, what we're going to do in this proof is we're trying to prove that angle A plus angle C is equal to 180. Okay, and let me look at my notes here because I did do this. Okay, right. Okay, so the idea behind this, let's see, I'm gonna need some colors here to work this with. Yeah. Okay. So I want to start off by saying what angle A is equal to, okay? Because angle A is an inscribed angle. And one of the things that we just learned is that inscribed angles are always half the measure of the central angle or the arc that they intersect. So let's take a look at the arc that this angle A is intersecting. So draw lines to where our angle is going to. So our angle goes from here to here, which means that this whole arc, B to C to D, okay, that's the arc that that angle A is intersecting, which means that that angle A is half the measure of arc BCD, this right here. So if this was 100, that would be 50, okay? Okay. In the same way, we can look at angle C. Okay. Okay. Angle C is another inscribed angle. Okay. So I can figure out what angle C is equal to by looking at the arc that it intersects. So here's the sides of that angle, and that's connecting from B to A all the way to D. Okay. So this is the arc that that angle C is intersecting. So that means that angle C is going to be half the measure of arc B, A, D. Okay? All right. So if we wanted to rewrite this statement, so angle A plus angle C, okay, we could say that angle A plus angle C, actually I like to do everything with organized color, so let's do that, okay, is equal to what A and C are equal to. So really this is equal to 1/2 BCD plus 1/2 BAD. So basically I'm just substituting in what we said angle A and C were, 1/2 of BCD, 1/2 of BAD, substituting that in there and there. Okay, now if you know your math and your distribution rules, then you know that if you have 1/2 and 1/2 in a statement, you can take that out and then put the rest of it in parentheses. So we're going to take that 1/2 out to the side, okay? And in parentheses, we're going to have our BCD plus BAD, okay? So A plus C is equal to this, which is equal to 1/2 of BCD plus BAD. But if you look at these two arcs, so here's BCD in green, and here's BAD in pink. If you add these arcs together and put them together, they make a full circle. They cover the entire circle. And we know that a circle, the degree of a circle, is 360. So that means that whatever this arc is and whatever this arc is, if you add them together, those measurements together are going to be equal to 360 because you're going a full circle. So really, when we say that A and C is 1/2 of BCD plus BAD, we're really saying that it is 1/2 of 360, because if you combine these, they sum to 360. Okay, well, 1/2 of 360 is equal to 180. And that's how we get, therefore, angle A plus angle C is equal to 180 degrees. Okay, and this little 3 dots is just, you know, something from college way back when. Just stands for therefore. Okay, this means therefore. Okay. Okay, so that's the proof of why this works. All right, so now that we've seen the proof, let's go look at an example. All right, and this example is going to be a little bit more challenging. I wanted to have the example in your notes be a harder example rather than an easier example. So that way, you know, if you experience some of those harder questions, you have something to look back on. So, okay, let's see. I do want to make this circle relatively large because I want to be able to write inside of it. Okay, so let's see, we put our center about there, and yeah, that should be big enough, I think. Okay, all right, so that's about how big we're going to make this circle for this example. And just like the proof was, just like the notes are, we're going to have this circle be A, B, C, D. And you can kind of put these points around the edge. A, B, C, and D, like that. And then we'll connect them. And just FYI, you know, we're going to go in and put some measurements here, and these are measurements that I got off of the PowerPoint that I made. But this is not drawn to scale, so the measurements may not be totally accurate, but this is just a model, you know, to help you understand an example. So let's say that we're given, what are we given here? I wanted to do, so we're given this, that, and that. Okay. All right, so let's say that we know that this is 70 degrees, this arc right here. This is 120. I'm going to change it a little bit from the PowerPoint. And let's say that we know that this is 80 degrees. Okay. And given those three pieces of information, we want to go in and when we want to find a couple of different things. So we want to find the measure of angle A, the measure of angle D, the measure of angle B, and we also want to find what is the measure of arc CD and arc AD. Okay. Oh. Okay. So the easiest thing to start with is getting angle A, right? Because angle A and angle C are the opposite angles in a cyclic quadrilateral, which means that these two things are supplementary. So basically, if I want to get angle A, I just need to subtract 180 minus 80, which is 100. Okay? So that means that this angle here is 100 degrees. Okay. Now, getting angle B and D is going to be a little bit more challenging. Since we don't know what either B or D are, we can't use the fact that that opposite angles are supplementary because we don't know what they are. Also, do not assume that these things are congruent. Remember, 90% of the time in your examples, or the practice problems that you're doing, these are not diagrams that are drawn to scale, which means that just because they look like they might be the same doesn't mean that they are the same in real life. So we don't ever want to assume that those things are congruent. Here's what we do want to do. So this is going to kind of pull from some of the stuff that we talked about in the proof. Remember that because this is a cyclic quadrilateral, so it's inscribed in the circle, that means that every single one of these angles that are on the edge of the quadrilateral are also inscribed angles, which means that you can use the inscribed angle theorems that we've been talking about. The fact that an inscribed angle is half of the arc that it intersects. And that's what we're going to use to help us get D. Okay? D is an inscribed angle. Let's look at the arc that angle D is intersecting. Okay? So here's our angle. The arc that it intersects goes from here all the way to here. Okay? So what we can do then, we know what the two pieces of this arc are, 70 and 120. So we can add them. Okay. 70 plus 120 is 190. Okay. So that's the measure of the arc from A to B to C. Okay. And since this is an inscribed angle, it means that it's going to be half that. So 190 divided by 2 means that this angle D is 95 degrees. Okay. All right. And then once you know what angle D is, then it's easier to get angle B. Because now that we know what one of these is, we can use the fact that they're opposites in an inscribed quadrilateral. So angle B and angle D should be equal to 180. So then I can do, I guess I'll do this in a different color just to keep all my stuff separate. So I can do 180 minus 95 to get that angle B would be 85. Okay. All right. Now, getting arc CD is a little tricky. So we're gonna, you'll notice that, like, you know, part of the problem here is that there is no inscribed angle that connects directly to these points C and D. You know, ideally, and what would make this problem a little bit easier, if there was an angle, you know, connecting like that or something to those 2 points C and D, and then we could just say, oh, well, times that by 2, and then we'll know what CD is. But there is no inscribed angle that directly intersects the arc CD. Now, what we do have, okay, we have this inscribed angle A. Actually, I'm going to use pink for that since I went ahead and used pink for that. Okay. So this inscribed angle A doesn't connect directly to CD, but it contains CD. So CD is part of the inscribed angle A. So A goes from here all the way over, okay, to here. Now the reason that this is useful is because even though I don't know what this piece is, I do know what this piece is. So if I can figure out how much is from here all the way to here, then I can subtract this piece to get this piece, which is CD. And the way that I'm going to get the measurement of here all the way to here is by multiplying my inscribed angle times 2, okay, using that theorem again. So 100 times 2 means that this arc from B to C to D is 200 degrees, okay? Then I can take that 200, subtract what I have here, the 120, okay, and that leaves me with 80 as the measure of arc CD. Okay, now that technique that we just used is pretty much going to be the same technique that we're going to use to get AD. There is no inscribed angle that connects directly to AD, but there is an inscribed angle that has this part CD and goes from C to D to A, so from here all the way to here. So if I can figure out what this entire arc is from here all the way to here, then I can subtract what we just got, the 80, to get what's left, which is over here. Okay. All right, I'm going to use yellow for this. So here's our full arc from A to D to C. Okay. So the inscribed angle that connects to this full arc, okay, so here's this point, this is the angle that connects to that arc, that angle B. Okay. My colors are all starting to blend together, but oh well. Okay, so the inscribed angle is 85. Okay. Multiplying 85 times 2, okay, gives us that the full arc is 170. So the 170 is from here to here to here. That full arc, taking this inscribed angle and multiplying it by 2. I guess I could have used blue there. Oh well. Okay. So then if I want to get what's this piece is, that piece AD, I'll use purple here. Okay, so here's this, what we want is just this piece. Then I just need to subtract what we have here, that 80. So 170 minus 80, which is right here, okay, leaves us with 90 as the measure of arc AD. Okay. All right, and that's pretty much it for these notes today. So if you have any questions, please leave them in the comments section. When I send out the Remind 101 for this video, I'm actually also going to give you guys a Google code and that code is going to be specifically for my class and these videos. I'm not going to put that Google Classroom code on our other geometry Google Classroom because that is for all of geometry, all of the teachers, and I don't want there to be any kind of confusion about what's expected. So this is just going to be a Google Classroom that is specifically for these extra videos that I've been making, where we do the notes just like we would have done if we'd had class. So when I send out that Remind 101 with that code, feel free to go in to that Google Classroom, and if you have any questions about the notes that we took today, if you have questions about how I solved this example, if you have questions about the proof that we did, you know, feel free to post those questions to that Google Classroom. Also, if you have been struggling with some of the problems that have been on the Learning at Home site, you can also ask questions on that Google Classroom regarding the Learning at Home site. If there's an example that you're not sure how to do or anything like that, you can post those to that Google Classroom. There was one other thing I wanted to say, but now I'm forgetting. Oh, that's right. I also, on that Google Classroom that I'm going to send out once I send out the remind for this video, I posted an assignment. Now, again, that assignment is not going to be graded. It is not by any means required. It is just, I wanted to give you something to practice if you wanted some extra practice, you know, to do from home, since we've been doing these notes. And notes are great, but you also have to have some experience with it yourself if you're really going to learn it. So that's what that practice is for. Not a graded practice, just for you to help your learning at home. So yeah, I hope you guys are doing okay, and take care until the next video. Bye.